Hello everyone, welcome back to another lesson in this machine learning series. This is Machine Learning 101, where we're going to be understanding all the basics from the ground up on what machine learning is and why it matters. So let's dive right in. So first of all, what is machine learning? Machine learning is a way to teach computers to learn patterns from data rather than relying on hard-coded rules. So a simple analogy, if you think of a toddler learning to recognize animals by seeing pictures, over time they figure out which ones are dogs, which ones are cats, without you specifically coding instructions like, oh, dogs have 4 legs, they bark, etc. So in the same way, a machine learning model will see many examples and develop its own rules and classify or predict the outcomes. Brief history, so it was pioneered in the mid-20th century with simple perceptrons, which are the early neural networks, and it took off when we had more data and more computing power by the internet era. So this sparked revolutions in terms of things like speech recognition, image analysis, recommendation systems, and more. So these are the things that we use machine learning for today, and many more. Again, traditional programming versus machine learning. So with traditional programming, you, the programmer, needed to define exactly how the computer should solve a problem through explicit instructions. So an example, if you want to calculate payroll, you write all the logic for taxes, benefits, deductions, etc. The machine learning approach is that you let data plus a chosen algorithm determine the rules. So another example here, instead of telling a spam filter, look out for all these keywords, you feed it tons of emails labeled spam or not spam, and so over time the model figures out which word patterns or sender info correlate with spam. So in other words, the key difference with traditional programming and machine learning is that one is rule based and the logic or the commands are explicitly written, whereas with machine learning it is all data driven and the algorithm then infers from the examples what to do. Okay, different categories of machine learning. So there are many different categories and tools when it comes to machine learning. So the first one let's discuss is supervised learning. So this is where our machine learning model is trained on labeled data, where we know what the correct answer is. So if we think back to the example I gave earlier about a cat and a dog, with supervised learning we would label the image, this is a cat, and with a dog, this is a dog. So the images will be labeled, we already know what the correct answer is, and it's just a good way when we feed new data into the machine, it's got this labeled data and it's simply sorting, okay, this one's got whiskers, yeah, it's a cat, this one barks, okay, it's a dog. We use it for things such as predicting house prices, otherwise a technique known as regression, and classifying emails as spam or not spam, known again as classification. So how does this contrast with unsupervised learning? So with unsupervised learning, the model is given unlabeled data and tries to find the patterns on its own. So there's no necessary right answer, let's say. Some examples is grouping similar customers together, this is known as clustering, and identifying unusual transactions, known as anomaly detection. So we'd use unsupervised learning for things such as, if you think about Google or Amazon, for example, having many different users and customers, and we want to give product recommendations to these users, we can look for patterns in the users' behaviors and the sites that they go to and the things that they click on to then suggest product recommendations to them based on these patterns. We provide customers, grouping them together, and then provide them products and services based on the patterns that these different groups of people have in common, if that makes sense. Or if you use the anomaly detection example, this is where we would use machine learning for things such as fraud detection systems, when we can see, okay, this is a regular pattern of transactions, but then we see, okay, there's suddenly a big bulk of money has suddenly just come in or gone out, or the spending patterns are much more frantic now. then this is a way that we can use machine learning in that sense for fraud detection. Is why sometimes with some card services, some bank services, that you'll find that your card will be blocked when you've been spending, very frantically. Maybe it's just been payday and you're spending away, very frantically. But sometimes your card can get blocked, and then you need to insert the card and insert your PIN again to actually unblock it, because it's just a way to mitigate against fraud, essentially, where they're seeing that you're spending quite frequently, and it might be, especially if it's an unusual pattern of spending, which you don't usually do. So those are some examples of what we can use, supervised and unsupervised learning for. Next up, we have reinforcement learning. This is where the model learns by interacting with an environment, receiving rewards or penalties. Examples are game playing AIs, things like chess and Go, where it receives rewards or penalties depending on the good moves and bad moves that it makes. Or again, in the realm of robotics, where it's learning to navigate and pick up objects, essentially. So essentially to do with receiving rewards and penalties to reinforce good or bad behavior. Why machine learning is important? It allows for us to handle complex problems. So some tasks are simply too complex or dynamic to solve with fixed rules, like self-driving cars, which is crazy. If we mentioned this some years back, it was only the things of sci-fi, but machine learning actually allows for this to become possible. Also, automation and efficiency. So models can automate repetitive tasks and uncover insights in large data sets. Examples are recommendation engines on e-commerce sites, like we discussed. Personalization. So tailor user experiences from curated playlists on Spotify to content recommendations on Netflix. And of course, continuous improvement. So models can adapt as more data comes in, like a living system that simply just keeps on learning. Some other quick real-life examples. Machine learning models decide which posts you see first based on your past likes and interactions. Again, we've mentioned about email spam filters. A classic example learned from millions of labeled emails. Things like voice assistants, Siri, Alexa, Google Assistants use speech recognition machine learning models. And also in the field of healthcare, machine learning assistants in diagnosing diseases by analyzing medical images or patient data, and many, many more. So wrapping up now, so key takeaways from today's lesson. Data-driven learning. Machine learning learns from data, unlike traditional programming where all rules are coded. So machine learning is data-driven. There's a few major different types. So we have supervised, unsupervised, and reinforcement learning, which each serve different purposes depending on the outcome you are trying to achieve. Ubiquitous technology. Machine learning is everywhere, from spam filtering to self-driving cars. It's very vast in terms of its application. And of course, the growth factors. So the explosion of machine learning is driven by big data and increased computing power. And last little lesson recap. Machine learning definition. It is teaching computers to learn from examples rather than explicit instructions. Machine learning took off due to an abundant data and better computing resources. Traditional versus machine learning. Remember, traditional programming is rules-based, hard coding in the logic explicitly, telling the program exactly what you want it to do at each given stage, versus a data-driven learning approach. The main categories, as we said, are supervised, unsupervised, and reinforcement learning. The real-world impact can be used for things such as social media feeds, spam filters, voice assistant, healthcare recommendation, product recommendations, you name it. And we're going to go on to the next steps, which is data prep and EDA, which is the backbone of successful machine learning. So I'll see you in the next one. Bye bye.